In case you were wondering, the answer to the question below here was because it would, if it doesn't show both solutions, means it will make it a function because it only shows one output for the input. All right, so example 2, this is the formula it's asking you to use. A bowling game that cost 50 cents in 1960 might cost $3 in 2010. What's the annual growth rate? So Y is what the cost will be in the future, or the later date. 50 cents is what it starts with. It's like the principal of your loan, but it's not a loan or investment. It's not an investment, but it's the idea. Inflation's kind of like an investment. That's how stocks grow and how investments grow, because inflation and all the other increasing rates then give more worth to your money. All right, and then 50 is the years that it's taking from 1960 to reach 2010, and G is the growth rate we don't know. So we're going to solve this for G. This 50 cents is a coefficient, so I'm going to divide by 50 cents, which is going to give us $6 out here, and I have a growth rate then to the 50th power. So, and then they want us to take each side to undo this 50th exponent. I'm going to take it to the 50th root, but we don't have to do the square root like notation like we did at the beginning, because we actually now know we can use the exponent as a fraction and it means the same thing. So these two fractions I'm looking as 50 over 1 times 1 over 50. That's the math I'm doing, because when you take a power to a power, you're multiplying. So I'm looking at this math. What's 50 times 1? 50. 1 times 50? 50. But what's 50 divided by 50? Just 1. So this whole exponent turns into 1. So this is 6 to the 1/50th equals G to the first. So what is my growth rate? I'm going to take 60. I'm going to put in 1 to the 1/50th. And my growth rate is 1.036. So that would be G. The cost grew about 3.6% annually. So this would be, it's a growth rate because it has the 1, but the rate of how much it's actually increasing every year, it's increasing by 3.6%. Okay. And this was annually because we already took into consideration the 50. This decimal goes in for G. So that is the rate for every year. It's going to increase 3.6% annually. All right, example 3. The volume V of a cone with radius r and height is given by that function. A, give a formula for radius in terms of V. So please pause it and see if you can rearrange it. So you're trying to get it to be an r equals and then have V in part of your function. So see if you can figure it out. Your answer should be this. You can use the 1/3, or you could use the little 3 with your root symbol. This is more tedious to write and usually more confusing if you write your 3's really large or you space them out strangely. Having the exponent of a fraction is a lot simpler for people to communicate well and clearly. Part B, a cone with radius r and height equal to its radius. So height is equal to radius. And it has a volume of 660. So my volume is 60. And they're wanting us to find its height, which is find its radius. And so this cube rooted is my radius, which is also my height. So I'm going to take the 180 that I get, divide that by pi, and type it in right. So 180 divided by second, pi, there we go, and to the 3rd power. So the height is about 3.855 millimeters. Alrighty. And then read page 563 and answer the following questions with at least 2 supporting details. Yes, pause, do that, come back. So you've looked at the graphs, and now Can you answer the question, how many real nth roots does a real number have? I answered earlier, you either have 1 or you have 2. But what are the criteria to have 1 or 2? Please note that what I'm writing now is not the complete answer because I'm not writing complete sentences. I'm using it as a tool to accompany my voice and what you've already read and what you've already learned and figured out as a pattern throughout this whole thing. Page 564 does put these into the pattern. So every positive real number has 2 real nth roots when n is odd. Okay, and it has, I totally wrote that wrong. This is even, n is odd. So an example would be, how many square roots are there for, I'll do 16. The square root of 16 is going to just be, I did that again wrong. The square root of 9 is just, n is odd. N is always the root that you're looking at. So if I'm looking at a square root, n in that case is 2, which is even. So square root of 9, that will have 2 answers. Square root of 16 will have 2 answers because n is even. N is the square part. What if I have the cube root of 8? That's just positive 2. If I have the cube root of negative 64, that's just negative 4 because n is the odd number because it is the outside of your radical. Okay, those are for positive numbers. If you're a negative real number, then you either have 0 or 1 real nth roots. 0 is when n is even, and 1 is when n is odd. So this is when n is. So if n is even, so I want the square root of negative 4, and then this would be like the cube root of negative 27. Okay, so for this negative 27, I'm going to have, the answer is negative 3, because you have negative 3 times another negative 3 times a negative 3. So the cube root of negative 27 is a negative 3. Now, is there any number that's the same number that I can multiply by itself 2 times and get out a negative number, specifically negative 4? No, because if I have 2 negatives, they're going to make a positive. If I have 2 positives, they'll make a positive. So there is no real root that will make this true, thus it is 0. Because there's no real root. These are 0 real roots. This is 1 real root. This is 1 real root. This is 2 real roots. Okay? They are real. Real roots for a real number. All right, example 4. So we have square root of negative 64 for complex numbers and confirm the result is a square root of negative 64. So I don't know. I don't think we have a complex. We don't have a complex. Oh, yeah, we do. Okay. Complex mode. So under modes, next to real, go to the a plus bi. That's your complex mode. And so then go to square root of negative 64. Hey, it gives us an 8i. So that's what our book tells us it should get out. So if I look at that, they're saying the square root of negative 64 is 8i, which means that 8i times another 8i should get me 64 times a negative 1 is negative 64. Because this sentence is true, this math sentence, I know this is true. Okay, and our last page is just going over homework. Yes, it is numbers 1 through 24. These are all the 3 things you should have learned from today's video.